Hey class, welcome to the last exercise in chapter 2, fractions and ratios. Today we'll be looking at exercise 2H, working with ratios. So recall from our previous lesson that ratios are comparisons of two or more similar quantities. Okay, they must have the same units, and that's what we mean by similar quantities. To write ratios in their simplest form, you need to find the highest common factor of each part of the ratio and divide each part, so similar to how we simplify fractions. Ratios are effectively fractions flipped on their side. Equivalent ratios are formed by multiplying or dividing each part of the ratio by the same whole number as well. So just like we did with equivalent fractions in 2b, we are multiplying or dividing by the same number in our ratios to make an equivalent ratio. So 5 quick examples for you today. The first, we're going to write each of these in simplest form. So to do that, we need to identify the highest common factor of 4 and 16 is, of course, 4. So we divide each side by 4. 4 divided by 4 is 1. And 16 divided by 4 is 4. Hint, one of our parts is 1, so we can't simplify it any further. Let's try another. 3 to 9. So the highest common factor of 3 and 9 is, of course, also 3. So we'll divide each part by 3. We divide by the highest common factor, and we get 1 to 3. Now, hint, one of them is 1, so we can't simplify any further, but if you get a prime number somewhere in there and it's not a factor of the other numbers in the ratio, you've probably finished up with the simplification as well. Just a quick side note, if I flip this ratio and make it 3 9ths, that would simplify to 1/3. So just as a little side note, they are effectively the same thing. If you were to write this as a fraction, how would you simplify it? As a fraction, and then just flip it back to get your ratio. All right, this time we're going to fill in the blanks to make each ratio equivalent. So let me grab my green pen again. We need to think about what we've done to this 4 to get to 8. So 4 something equals 8. We've made it bigger, so we must be multiplying, and 4 times 2, of course, equals 8. So we're going to do the same thing to the 3. Whatever we do to one part, we must do to the other. 3 times 2 is 6. So our equivalent ratio of 3 to 4 is 6 to 8. Let's try another. Okay, we need to think about what have we done to the 5. Now 5 is in the same position as the 30, so that's how we know which parts we're converting to make it a 30. Well, 5 times 6 is 30. So, again, 2 times 6, just fit it. 2 times 6 is 12. So our equivalent ratio for 5 to 2 is 30 to 12. Last one now. 48 to 6 equals 8 to something. So what have we done to the 48 to get to 8? Well, 48 divided by 8 is, of course, 6. So 48 divided by 6 gives us 8. We'll do the same to the other side. 6 divided by 6 is 1. So our equivalent ratio, 48 to 6, is 8 to 1, which is similar to what we were doing over here with our simplifying of ratios. The highest common factor in this case here was 6, so dividing both sides by 6 gives us our simplified ratio, 8 to 1. In ratios, we never flip the side of the parts. They stay where they were. The numbers can just get bigger or smaller depending on whatever factor you multiply by. So in the first one it was 2, in the second one it was 6, and in the third we were dividing by 6 instead. As always, guys, if you have any questions, let me know. But otherwise, good luck with the work, and I will speak to you all very soon.